In this video, we're going to look at section 5.4 for pre-calc, which is on expanding and condensing logarithmic expressions. We're going to look at a few rules. The first one we're going to look at is the power rule. And the power rule is when we have a log and then on the inside we have a number to some power. You can just take that exponent and bring it down out front of the logarithm and then just multiply. So if we take a look at this in action down here, so for this one, we have log of 2 to the third power. So we'll be able to just bring this 3 down out front of this log, and we'll just do 3 times log of 2. In this second one, we again have log base 4 of x to the third. So our power is 3. So we're just going to bring that out front. So we'll have 3 times log base 4 of x. Then the second rule that we have is the product rule, and that's when we have the log base anything of some product. Okay, so you got multiple factors in here. Then you can just split this up and put each factor in with the log. So we'd have log base b of r, log base b of s, and then we put a plus between them. So we're going to bring this log to both or all of the factors and then add them together. So for number 1, we've got multiple things happening here because we see that exponent of a 3. So we're going to want to bring that down first. So we're going to have 3 times the log of 25 times x times y. And then if you ever, so now we're going to be dealing with factors. So now when we have multiple factors on the inside here, if you have any numbers that are not prime, you would want to break them down to prime numbers so that you don't have hidden factors in here. So we're going to have 3 times this whole thing. So I'm just going to kind of put a parenthesis here, and then I'm going to rewrite 25 as 5 times 5, or 5 squared in this case is what I'm going to write it as, and then times x and times y. So now we see that we have 3 different bases within this logarithm. We have 5 squared, we have x, and we have the y. So we're going to split this up into 3 logarithms. So we're going to have 3 times log of 5 squared, and then plus log of x, and then plus log of y, dealing with all 3 of those bases. So that 5 to the second, the x, and the y, splitting those all each into a logarithm. Then we would also want to bring this 2 out front of just this logarithm. So we've got 3 on the outside, and then we've got 2 log of 5. So 2 times log of 5 plus log of x, and then plus log of y. And then you could multiply that 3 into everything and have 6 log of 5 plus 3 log of x plus 3 log of y. And this would be the expanded answer. And just like the word expand, it's long, right? So we're taking this single logarithm and expanding it out. So then number 2, I'll just rewrite the 9 first. So 9 is 3 times 3. So I'll just write that as 3 squared. And then we have times y. So we see 2 different bases in there. So we're going to have 2 different logarithms when we write these out. So we'll have log of 3 squared. And then since we're multiplying on the inside, we'll add these separate logs. So then plus log of y. And then, the last thing you'd want to do is just bring that 2 out front. So then instead of having, maybe I'll just erase it here. So instead of having the 2 up top here, we would just have the 2 out front. And then that would be our expanded version. All right, then let's use the product rule to condense. So that was expanding when we had one logarithm and we made it bigger. Now we're going to condense these. So when you're condensing logarithms, you just want to make sure that they have the same base. So these are both common logs. So these are just log base 10s. So we can put these together by multiplying the numbers. So multiplying these bases. So we're going to take the log of 2 plus the log of 4. So we'll combine this to one log and we'll multiply those inside. So we'll multiply 2 times 4. So then this would be equivalent to the log of 8. Number 4, so looking and we see that all of these logarithms are just base 10 logs. So we can take their insides and we'll be able to put these all back together with multiplication on the inside since we're adding these logs. So we'll put it as one single logarithm. And then on the inside, we'll take each of these and multiply them. So then we'll just have the log of 16 x squared y squared, and then nothing simplifies there. So that is our final version, or our solo single log condensed. Next rule is the quotient rule. So if we see a division within this logarithm, then we can separate it. And these should actually have b's on them right here. So it should separate to log base b of r, so the top number, minus log base b of s, the bottom number. So anything that's on the top, and then minus what's on the bottom. So in this first one, we see that on the top, we have x squared plus 1. And then on the bottom, we have x. So we're going to have two logarithms here. So we're going to have log of the top minus log of the bottom. So we're going to have log of x squared plus 1 minus log of x. Then in number 2, we see a 2 on top and we see a y on bottom. So we're going to have two logs subtracted again. So we'll have log of the top minus log of the bottom. So we'll have log of 2 minus log of y. And then that would be the expanded form. Then we can do this backwards again by using multiple rules here. So we're going to have quite a few rules that we see here because we see this 5 out front. Okay, and then we see the x on the inside, and we see this 2 out front here, and we see the xy inside. So first thing we're going to do is the power rule to bring these exponents back up. So then this is going to be ln of x to the 5th minus ln of xy squared. So this 2 is going to go to both of these. So I'll just write it out like that so you can see this. So it's ln of x to the 5th minus ln of x squared y squared, because that's going to go to both of those. So now that we've brought those powers up, now we can use the quotient rule. So now we have this x to the 5th first, and then we have the x to the 2nd, y to the 2nd, okay, being subtracted in another natural log. So then we're going to have the natural log of the first one divided by the second one. So we're going to have the natural log of x to the 5th over x to the 2nd, y to the 2nd. Then you can use your algebra rules because we see that we have a factor of x to the 5th on top and x squared on bottom. So x to the 5th over x to the 2nd simplifies to x to the 3rd. And then we still have that y squared on bottom. So then this would be our final simplified condensed logarithm. Number 4, so generally we don't necessarily want roots in our logarithms because our logarithms are dealing with exponents. So I'm just going to rewrite this one as x plus 5 to the 1/2 power, and then we have minus ln of x. It's really not going to matter in this case because that exponent isn't going to simplify at all. But just usually with logarithms, we don't necessarily use radicals. So this first part is x plus 5 to the 1/5, and then the second part is minus the natural log of x. So then we will have just one natural log when we put this back together, and we'll have that first part on top and then the second part on bottom. So on top we'll have x plus 5 to the 1/2, and then on bottom we'll have x. And then that doesn't look very simple, but that's our condensed to one logarithm answer. Then we have a change of base formula so that you can type these into your calculator, because the only log on your calculator screen is just, well, there's 2 logs. There's just the log, okay, so a log base 10. So log of whatever you type in. So if you have log of 12 or log of 121 or log of 12.7 or log of 4, this is always going to have a base of 10. So that's on your screen. And then also the natural log. So anytime you're evaluating a natural log, you can type that straight into your calculator. So if we're wanting to do a non-base 10, we have to use this formula, which says take the log of the input. Okay, so log base 10 of your inside divided by log base 10 of your base. So let me highlight the base in this one is 3, and then that input is 16. So we're going to do the log base 10, so a common log of the input divided by the common log of the base. So log base 10 of 16 divided by log base 10 of 3. You would type that into your calculator and then get your answer. So if you want to try typing that in your calculator to see if you are doing it right, I will give you the decimal answer here. So we've got the log of 16 divided by the log of 3. So you should get an answer of 2.5237. So you can try typing that in and making sure you're doing that right. So then for this second one, the base is 6 and the input is 10. So again, we will do log base 10 of the input divided by log base 10 of the base. So we'll do log base 10 of 10 divided by log base 10 of 6. And so if you type this into your calculator, you should get approximately 1.285. So just check and make sure you're doing that correctly. All right, then let's practice expanding logarithms here using all of our different rules. So in this first one, you can see that we have a product in here. So we have 4 times x. And then one thing you'll want to do is, since 4 isn't a prime number, we'll want to think of 4 as 2 times 2 or 2 squared. So that when we expand this, we'll be able to expand it as much as possible. So with this, we've got a product inside of this log. So we're going to be doing log base 3 of each of those factors and adding them together. So we have log base 3 of 2 squared. And then we have log base 3 of x. Then the final thing that you'll want to do is expand this 2 squared. So using the exponent rule to bring this 2 squared, okay, the squared exponent out front of this log. In the next one, we have multiplication, exponents, and division. First thing I would do here is if anything can simplify here, you want to do that. Okay, you can still use your algebra rules. So what I notice here is that 6 divided by 3 simplifies to 2. So I would want to do that first and just simplify that to a 2 on top. Because that will make your calculations simpler down the road, because otherwise you're going to have to simplify after you expand these logs. So then you'll notice that we've got that 2 times x squared on top, and now we just have the y on bottom. So the stuff that's on top is just going to be multiplication, because those are going to be products. And so we're just going to be adding those together. So we've got the log base 3 of 2 here, and then the log base 3 of x squared, and we're just adding those. Then we've got this division here. So this division is subtracting log base 3 of our bottom. So log base 3 of that y. With this next one, we have products and exponents. And so we see that we have this 5, we've got that times x to the third, we've got that times y, and then we've got that times z squared. So we'll expand this first, and since this is all products, it's going to be log base 7 of each one, and then added together. So we have 4 different products, so we'll have 4 different log base 7s, one for each factor. So we have log base 7 of 5 plus log base 7 of x cubed plus log base 7 of y, and then plus log base 7 of z squared. So then we'll just deal with these exponents now. So we have in this one, we have x to the third power on the inside. So then we want to take that exponent and move it out front. And then same with the z squared. So we've got a squared exponent there. And so we want to take that squared exponent and use the power rule and move it out front of that logarithm. So then this would be our expanded logarithm. And then the final one here, we have e to the 5th power. And so this just really has a power of 5, is really the only thing there that's happening. So we would just take and move that power out front. So we'll just grab that and move it out front of this. So then this is just going to be the ln 5 times the ln of e. And really, this is just 5 because this has a base of e. So ln of e is going to cancel. So we're just going to be left with 5. So this one actually just simplifies to 5. Then let's use our rules backwards and condense them. So now we're just going to be taking these insides and deciding what we need to do with them. So we're going to condense them back to one logarithm. In this case, we are subtracting. So these are going to go back into one logarithm, and it's going to be division. So it's going to be the first one on top and then the second one on bottom. So log base 4 of 7/10. Next one, we see some numbers out front. So we know that those are going to be powers. So we see that 5, we see the 7, we see the 4. And so we can just bring these up to the top. Okay, so we're going to bring those up. And then I'm just going to erase this out of there. So we brought that 5 up. We're going to bring this 7 up. And then we're going to bring the 4 up to the y. So bringing in those exponents, okay, is the start. Now we're going to take a look at the full insides here. And we're going to deal with whether we're going to multiply or divide these. So we're bringing this to one logarithm. So again, a log base 4, and we see that we have addition and subtraction. So that means we're going to have multiplication and division. So the ones that are added together are going to be multiplied on top. So this 2 to the 5th is going to be on top, and then the x to the 7th is going to be on top. And then on the bottom, we're going to have this y to the 4th because that one was subtracted, meaning that it's divided. So y to the 4th on bottom. And then really we should probably multiply this out to 32. Since that's 2 to the 5th power. All right, then this next one, we see that 2 out front there. So the first thing we're going to do is, again, bring that up to the x squared, or to the x and make it x squared. Okay, then we don't see, there isn't a number out front here. So now we'll be able to deal with these insides of x squared and 11. And we see that we're subtracting. So that means we're going to be taking log base 4 and we'll be dividing these. So we'll be taking the first one of x squared, and then we'll be dividing that by 11. So then this will simplify to log base 4 of x squared over 11. Then this final one, so I'm going to leave this 2 out front first. So I'm going to deal with this 20 and then the 4. So let's make this one logarithm first. And so we get 2 times, in this case, log base 3. And now this is going to be division, right? Because we've got subtraction. So it's going to be 20 over 4. And then we still have the plus 0.5. I'm going to write it as 1/2. And then log base 3 of 4. So then this is really just 5. So this is 2 times log base 3 of 5 plus 1/2 log base 3 of 4, right? So now we can take these front numbers here and we can move them up as exponents. So we've got in this first one log base 3 of 5 squared, and then we have plus log base 3 of 4 to the 1/2 power. So 5 squared is 25, and 4 to the 1/2 power, that's the square root of 4, that's just 2. So now we can put these 2 logs together. So we've got the 25 here, and we've got the 2 here, and we're adding these 2 logs of the same base, so we can combine them back to 1 log and just multiply these insides, right? 25 times 2. So then this simplifies to the log base 3 of 50 as our final answer.